Imagine waking up one day to find that the fundamental laws of physics have left us with a collection of riddles so perplexing that even our brightest minds throw up their hands in bewilderment. These aren't just academic puzzles gathering dust in university libraries. These are the kinds of mysteries that keep scientists awake at night, staring at blackboards covered in equations that seem to mock our attempts at understanding. Welcome to the strange world of unsolved science paradoxes, where logic bends, reality hiccups, and the universe seems to be playing an elaborate joke on anyone brave enough to ask why. You might think that after centuries of scientific progress, we'd have most things figured out by now. We've split atoms, mapped genomes, and sent robots to Mars. We've built computers that can beat chess grandmasters and telescopes that can peer into the hearts of distant galaxies. Yet for all our technological wizardry and mathematical sophistication, there remain corners of reality that stubbornly refuse to make sense. These paradoxes aren't just minor inconveniences or gaps in our knowledge that will be filled in next Tuesday. They're fundamental contradictions that strike at the very heart of how we understand the world. What makes these paradoxes so fascinating is that they don't emerge from obscure corners of theoretical physics or esoteric mathematical proofs. Many of them arise from the most basic questions you might ask about existence itself. Questions like, why does the universe exist at all? Why do we experience time moving forward? How can something come from nothing? These sound like the kinds of philosophical musings you might have during a particularly deep conversation at 3 a.m, but they're also legitimate scientific puzzles that have stumped researchers for decades. The beautiful thing about these paradoxes is that they reveal the limits of human understanding, while simultaneously pointing toward the profound mysteries that still await discovery. They remind us that, for all our scientific achievements, we're still like children building sandcastles on the shore of an infinite ocean of knowledge. Each wave that crashes brings new shells and treasures, but also washes away our carefully constructed certainties. Let's begin with perhaps the most mind-bending paradox of all, one that questions the very foundation of existence itself. It's called the paradox of something from nothing, and it goes something like this. Everything that exists must have a cause, right? Your coffee cup exists because someone made it. The tree outside your window exists because it grew from a seed. Even the most complex phenomena in the universe can be traced back through chains of cause and effect. But here's where things get strange. If everything needs a cause, then what caused the universe itself? Scientists tell us that the universe began with the Big Bang roughly 14 billion years ago. Before that moment, there was no space, no time, no matter, no energy. There was quite literally nothing. But how does something, especially something as vast and complex as our entire universe, spring into existence from absolutely nothing? It's like expecting a symphony to emerge from complete silence without any musicians, instruments, or even the concept of music. Some physicists have proposed that quantum mechanics might offer an answer. At the subatomic level, particles can pop into existence from what appears to be empty space, borrowing energy from the quantum vacuum, and then disappearing again in fractions of a second. Perhaps the entire universe is just a quantum fluctuation that happened to stick around. But this explanation creates its own problems. Where did the quantum vacuum come from? Where did the laws of physics that govern these fluctuations originate? We seem to be pushing the mystery back one step without actually solving it. Others suggest that maybe the question itself is flawed. Perhaps asking what caused the universe is like asking what's north of the North Pole. If time itself began with the Big Bang, then there was no before for a cause to exist in. But this answer, while logically consistent, leaves us with an even stranger conclusion. The universe, in all its complexity and beauty, simply exists for no reason at all. It's a brute fact, as philosophers call it, something that just is without explanation. Then there's the possibility that something did exist before the Big Bang, some primordial reality from which our universe emerged. But what was the nature of this reality? How did it give birth to space and time? And what, if anything, caused it to exist? No matter which direction we turn, we seem to bump into the same fundamental mystery. Either something can come from nothing, which violates our basic understanding of causation, or there's an infinite chain of causes stretching back forever, which seems equally impossible to comprehend. This paradox isn't just an abstract philosophical puzzle. It strikes at the heart of how we make sense of reality. We're pattern-seeking creatures who instinctively look for explanations, causes, and reasons. But when it comes to the ultimate question of why there is something rather than nothing, we find ourselves staring into an abyss of incomprehension. The paradox becomes even more perplexing when we consider the fine-tuning of the universe. The fundamental constants of physics, the masses of particles, the strength of forces, all seem to be set to precisely the values needed for stars, planets, and ultimately life to exist. Change any of these values by even a tiny amount, and the universe becomes a cold, empty void or collapses back on itself immediately after the Big Bang. This remarkable fine-tuning suggests that the universe isn't just a random accident, but something that was carefully crafted. Yet if there was no designer, no intelligence behind it all, how do we explain this extraordinary precision? Some scientists propose the existence of a multiverse, an infinite collection of universes with different physical laws and constants. In such a scenario, we happen to live in one of the rare universes where the conditions are just right for our existence. It's not that our universe is special, but rather that we can only exist in a universe that's compatible with our existence. This is called the anthropic principle, and while it's logically sound, it feels like a bit of a cheat. We're essentially saying that our universe appears fine-tuned because we're here to observe it, and we wouldn't be here if it weren't fine-tuned. But even the multiverse theory doesn't fully resolve the paradox. Where did the multiverse come from? What determines the laws that govern the generation of new universes? We've simply moved the mystery up another level without actually solving it. We're left with the same fundamental question. Why is there something rather than nothing at all? This paradox has profound implications for how we view ourselves and our place in the cosmos. If the universe exists for no reason, then perhaps our lives and everything we care about are ultimately meaningless. On the other hand, if there is some deeper explanation for existence, some fundamental principle or intelligence behind it all, then maybe we're part of something much grander than we can imagine. The paradox also highlights the limits of scientific inquiry. Science is incredibly powerful at explaining how things work, but it struggles with the question of why anything exists in the first place. It's a bit like having a perfect map of a country, but never being able to explain why that country exists, rather than just empty ocean. We can trace the evolution of the universe from the first moments after the Big Bang to the present day, but that initial moment remains shrouded in mystery. What makes this paradox particularly maddening is that it seems to resist any kind of resolution. Every proposed solution either pushes the mystery back another step or requires us to accept conclusions that feel deeply unsatisfying. We're forced to choose between something coming from nothing, an infinite regress of causes, or the existence of some uncaused first cause. None of these options sit comfortably with our intuitions about how reality should work. Yet perhaps that's the point. Perhaps these paradoxes exist to remind us that reality is far stranger and more wonderful than our everyday experience suggests. They force us to confront the limitations of human reason and to remain humble in the face of the cosmic mystery. They remind us that for all our scientific achievements, we're still explorers in a vast wilderness of the unknown. The paradox of something from nothing also connects to deep questions about consciousness and meaning. If we can't explain why the universe exists, how can we hope to understand why we exist? What does it mean to be a conscious observer in a cosmos that might have no ultimate explanation? These questions don't have easy answers, but they point toward the profound mystery of existence itself. In the end, the paradox of something from nothing might be unsolvable, not because we lack the right theories or sufficient data, but because it reveals a fundamental limit to what can be known or understood. It stands as a permanent question mark at the foundation of reality, a reminder that beneath all our scientific knowledge lies an ocean of mystery that may be deeper than we can ever fathom. And perhaps that's not such a bad thing. Perhaps a universe that could be completely understood would be a far less interesting place to live. The mystery keeps us humble, keeps us wondering, and keeps us searching for answers, even when we suspect that some questions might be too profound for any finite mind to fully grasp. So far, we've explored the profound mystery of how something might emerge from nothing, but that's just the beginning of science's most perplexing puzzles. Tonight, let's drift into another enigma that has baffled physicists for nearly a century, one that strikes at the very heart of what we thought we knew about reality itself. It's a paradox so strange, so counterintuitive, that even Einstein called it spooky, and it continues to haunt the foundations of physics to this day. Picture this: you have two particles, perhaps two photons, dancing through space. They've interacted once, briefly, intimately, and now something extraordinary has happened. They've become entangled, connected by an invisible thread that defies our everyday understanding of how the world works. Separate these particles by vast distances, send one to the edge of the galaxy if you like, and something remarkable persists. Measure one particle, observe its properties, and instantly, faster than light itself could travel between them, the other particle responds. It's as if they share a single identity scattered across space, as if the universe itself refuses to acknowledge the separation. This is quantum entanglement, and it presents us with what might be the most beautiful and disturbing paradox in all of science. Einstein, alongside his colleagues Podolsky and Rosen, first articulated this puzzle in 1935, not as a celebration of quantum mechanics, but as a devastating critique. They argued that if quantum mechanics predicted such bizarre behavior, then surely the theory must be incomplete. There had to be hidden variables, secret instructions carried by each particle that predetermined their behavior. The alternative was too unsettling to contemplate. That reality, at its most fundamental level, operates according to principles that mock our intuitions about locality, causality, and the very nature of existence. For decades, this remained a philosophical debate, an intellectual exercise played out in the ivory towers of theoretical physics. But then came John Stuart Bell in 1964, an Irish physicist who transformed armchair philosophy into experimental reality. Bell's theorem, elegant in its simplicity, yet profound in its implications, showed that Einstein's hidden variables could be tested. The universe would have to choose: either locality is an illusion, or realism itself is nothing more than a comforting fairy tale we tell ourselves about the nature of existence. When the experiments finally came, conducted by Alain Aspect in the 1980s and refined by countless researchers since, the results were unambiguous and deeply unsettling. The universe had chosen, and it had chosen, the impossible. Particles separated by vast distances do indeed influence each other instantaneously. The hidden variables that Einstein hoped for simply don't exist. Reality, it seems, is far stranger than even our strangest theories had dared to suggest. But what does this actually mean? How can we possibly wrap our minds around a phenomenon that seems to violate everything we know about space, time, and causality? The answer depends on which interpretation of quantum mechanics you embrace. And here lies another layer of the paradox. We have a theory that makes predictions with stunning accuracy, that has given us lasers, computers, and MRI machines, yet we still can't agree on what it actually means. In the Copenhagen interpretation, the standard view taught in universities worldwide, particles don't have definite properties until they're measured. Before observation, they exist in a ghostly superposition of all possible states. It's only when we peek behind the curtain that reality crystallizes into the concrete world we experience. Under this view, entangled particles share a single quantum state that transcends space and time. They're not separate entities sending signals to each other. They're aspects of a single, indivisible whole. But many physicists find this interpretation deeply unsatisfying. How can mere observation create reality? What constitutes a measurement? Where exactly does the quantum world end and the classical world begin? These questions led to alternative interpretations, each more mind-bending than the last. In the many worlds interpretation, every quantum measurement doesn't collapse possibilities into a single outcome, but instead splits the universe into multiple parallel realities. When you measure one entangled particle and find it spinning clockwise, there's another universe where you measured it spinning counterclockwise. Entanglement isn't spooky action at a distance, it's the correlation between different branches of the universal tree. Every possible outcome happens somewhere, and we simply experience one branch among countless others. Then there's the pilot wave theory, which suggests that particles do have definite positions and properties, but they're guided by a quantum field that connects everything in the universe. This field, invisible and undetectable, carries information instantaneously across any distance, creating the illusion of spooky action at a distance. It's a deterministic theory hidden beneath quantum randomness, where the universe follows precise rules even if we can never fully know them. Each interpretation solves some aspects of the entanglement paradox while creating new mysteries. They're like different languages trying to describe the indescribable, each capturing some essential truth while missing others. What they all share is the recognition that our classical intuitions about reality simply don't apply at the quantum level. The practical implications of entanglement are staggering. Quantum computers promise to solve problems that would take classical computers longer than the age of the universe. Quantum cryptography offers unbreakable codes, protected by the laws of physics themselves. Quantum sensors could detect gravitational waves with unprecedented precision or reveal the faintest whispers of dark matter. We're learning to harness the very paradox that once seemed like a mere curiosity. Yet for all our technological mastery, the fundamental mystery remains. How can information appear to travel instantaneously between distant particles? Why does nature seem to prefer correlation over locality? What does it mean for our understanding of space and time if the universe is fundamentally non-local? Some physicists have suggested that entanglement reveals something profound about the nature of space itself. Perhaps what we perceive as empty vacuum is actually a web of quantum correlations, a fabric of entangled possibilities that connects every point to every other point. Maybe space and time aren't fundamental features of reality, but emergent properties of a deeper, more connected universe. Others wonder if consciousness itself plays a role in the quantum measurement process. If observation collapses quantum superpositions, what exactly constitutes an observer? Does it require consciousness, or is any interaction sufficient? These questions blur the line between physics and philosophy, between science and metaphysics, in ways that make many researchers deeply uncomfortable. The entanglement paradox also raises troubling questions about free will and determinism. If the universe is truly non-local, if distant events can influence each other instantaneously, what does this mean for our sense of agency and choice? Are we truly independent actors in the cosmic drama, or are we part of a vast interconnected web where every decision reverberates across space and time? Perhaps most unsettling of all is what entanglement suggests about the nature of reality itself. We like to think of the universe as composed of separate objects interacting through space and time. But entanglement hints at a more fundamental truth, that separation might be an illusion, that the universe might be a single, undivided whole, masquerading as a collection of independent parts. This connects to ancient philosophical and spiritual traditions that have long suggested the ultimate unity of all existence. The mystics spoke of the interconnectedness of all things, of the illusion of separation that veils a deeper unity. Modern physics, through the strange lens of quantum entanglement, seems to be rediscovering these insights in the language of mathematics and experiment. Yet science demands more than poetic metaphors. It requires precise predictions, testable hypotheses, and reproducible results. The challenge is translating the mystical implications of entanglement into the rigorous framework of scientific investigation. How do we study the unstudyable, measure the unmeasurable, understand the incomprehensible? Some researchers are exploring whether entanglement might be the key to understanding other cosmic mysteries. Could quantum correlations explain the apparent fine-tuning of physical constants? Might the universe's initial conditions have been established through some vast entanglement process that we're only beginning to glimpse? These speculations push the boundaries of both science and imagination. The paradox of quantum entanglement remains one of the most active areas of research in modern physics. New experiments continue to push the boundaries of what's possible, creating entangled states involving more particles across ever greater distances. Each breakthrough deepens the mystery, even as it expands our technological capabilities. What makes this paradox particularly maddening is that it works perfectly in practice while remaining incomprehensible in principle. We can predict with extraordinary precision how entangled particles will behave. We can use their properties to build revolutionary technologies. Yet we still can't explain why any of this should be possible. It's as if we've learned to speak a language fluently without understanding what the words actually mean. This might be the deepest lesson of quantum entanglement, that the universe is under no obligation to make sense to us. Our brains evolved to navigate a world of medium-sized objects moving at moderate speeds, not the quantum realm of superposition and entanglement. Perhaps the real paradox isn't that quantum mechanics is strange, but that we expect it to conform to our everyday intuitions. As we drift towards sleep tonight, consider the possibility that you are already entangled with the universe in ways beyond imagination. The particles in your body were forged in the hearts of ancient stars, scattered across the cosmos, and somehow found their way into the intricate patterns that make up your consciousness. Every breath you take contains atoms that have travelled billions of years to reach you, carrying with them the quantum correlations established in the universe's earliest moments. The boundary between you and the rest of existence might be far more porous than it appears. In the quantum realm, separation is an illusion, connection is fundamental, and the universe reveals itself as a single, magnificent, incomprehensible whole. The spooky action at a distance that so troubled Einstein might be nothing more than the universe reminding us that, at the deepest level, distance itself is just another comfortable fiction we tell ourselves about the nature of reality. And so the paradox persists, beautiful and bewildering, a reminder that the universe holds secrets that may forever elude our understanding. In trying to comprehend quantum entanglement, we confront not just the limits of our knowledge, but the limits of knowledge itself. The mysteries we've explored together reveal the strange beauty of our universe, where time may flow backward, space might be illusion, and consciousness itself could be the ultimate paradox. We've seen how quantum mechanics whispers that reality might exist only when observed, how particles seem to dance through multiple states simultaneously until the moment we decide to look, and how the very act of measurement appears to collapse infinite possibilities into singular truths. Yet perhaps the deepest paradox isn't in the equations or the experiments, but in the fact that we conscious beings can contemplate our own consciousness at all. Consider this final enigma. If everything we've discussed is true, if reality is indeed as malleable and observer-dependent as quantum theory suggests, then what does that make us? Are we merely biological computers processing information, or are we something more fundamental, active participants in the creation of reality itself? The hard problem of consciousness remains unsolved not because we lack sophisticated instruments or elegant theories, but because consciousness might be the one thing that cannot be reduced to its components without losing its essence entirely. Some physicists now propose that consciousness isn't produced by the brain, but rather that the brain serves as a kind of antenna, tuning into consciousness the way a radio receives signals from invisible waves. Others suggest that consciousness is woven into the very fabric of space-time, a fundamental feature of the universe as basic as mass or energy. If this is true, then every observation, every measurement, every moment of awareness is literally helping to write the story of reality as it unfolds. This brings us to perhaps the most humbling realization of all. The more we discover about the universe, the more we understand how little we truly know. Each answer births new questions. Each solution reveals deeper mysteries. The quantum world operates by rules that defy our everyday intuition. Particles behave in ways that seem impossible, and time itself might be nothing more than a persistent illusion created by the flow of entropy. Yet somehow, from this chaos of uncertainty and paradox, the ordered beauty of existence emerges. These unsolved paradoxes aren't failures of science, but invitations to wonder. They remind us that the universe is far stranger and more magnificent than our ancestors could have imagined, and probably stranger than we can imagine today. They suggest that reality itself might be more like a conversation than a monologue, requiring both the observer and the observed, the questioner and the mystery, consciousness, and cosmos dancing together in an eternal waltz of discovery. So as you drift off tonight, remember that you are not separate from these cosmic mysteries. You are part of them. Every thought you think, every dream you dream, every moment of awareness you experience is connected to the deepest puzzles of existence. You are quite literally made of star stuff, organized by principles we're still struggling to understand, conscious in ways that remain profoundly mysterious. The mystery of consciousness continues to perplex us at every turn. We've explored how the universe emerged from nothing, how particles dance together across impossible distances, and how reality might depend on observation itself. But now we venture into perhaps the most intimate paradox of all, the hard problem of consciousness. This isn't just about brain activity or neural networks, or the complex machinery of cognition. It's about something far more fundamental and far more strange. The hard problem, as philosopher David Chalmers famously termed it, asks a deceptively simple question. Why do we have subjective experiences at all? Why doesn't the human brain simply process information like a sophisticated computer, responding to inputs with appropriate outputs, without any inner experience, without any sense of what it feels like to be you? After all, from a purely functional standpoint, consciousness seems almost redundant. We could imagine biological robots that behave exactly like conscious humans, that speak about their experiences, that create art and fall in love, and contemplate the stars, but with no actual inner experience happening at all. No lights on inside, as it were. Yet here you are, not just processing these words, but experiencing them. There's something it's like to be you right now, listening to this voice, perhaps feeling the weight of your body, aware of thoughts arising and fading in your mind. This subjective first-person experience, this felt quality of being, is what philosophers call qualia. And qualia present us with one of the deepest mysteries in all of science. Consider the redness of red, Not the wavelength of light at roughly 700 nanometers, not the way your cone cells respond to that wavelength, not even the neural patterns that fire in your visual cortex when you see a ripe strawberry. We're talking about the actual experience of redness, that quale, that felt quality that seems to emerge from all that physical processing but somehow transcends it entirely. Science can map every step of visual processing, from photon to perception, but the experience of red itself remains mysteriously outside that chain of explanation. This is what makes consciousness so paradoxical. Everything else in the universe, from the spin of electrons to the birth of stars, can be described in terms of structure, function, and behavior. But consciousness seems to require something more, an explanation for why there's an inner dimension to experience at all. It's as if the universe, in creating brains complex enough to model reality, accidentally created something that models what it feels like to exist. The puzzle deepens when we consider that consciousness appears to be unified. Right now, you're not having separate experiences of hearing these words, feeling your breathing, being aware of your surroundings. All of these streams of sensation and thought are woven together into a single, coherent experience of being you in this moment. Neuroscientist Gerald Edelman called this the unity of consciousness. And it's deeply mysterious because your brain is not unified at all. It's a collection of specialized regions, each processing different types of information, connected by networks that are constantly chattering with each other. So how does this distributed, massively parallel biological computer generate the seamless, unified experience of being a single conscious self? It's like asking how a symphony orchestra, with dozens of musicians playing different parts, manages to produce what sounds like a single, coherent piece of music. Except in the case of consciousness, there's no conductor, no score, and somehow the music becomes aware of itself. Some scientists have proposed that consciousness emerges from the integration of information across different brain regions. Giulio Tononi's integrated information theory suggests that consciousness corresponds to integrated information, the amount of information that a system generates above and beyond its parts. The more integrated the information processing, the more conscious the system becomes. It's an elegant idea, but it leads to some strange implications. By this theory, any system that integrates information, including, potentially, certain arrangements of photodiodes or even protons, could be conscious to some degree. Others have suggested that consciousness arises from quantum effects in the brain. Physicist Roger Penrose and anesthesiologist Stuart Hameroff proposed that consciousness emerges from quantum computations occurring in microtubules within brain cells. While most neuroscientists remain skeptical of quantum theories of consciousness, the idea refuses to die entirely. Perhaps the weirdness of quantum mechanics, its observer-dependent reality, its non-local connections is precisely what's needed to explain the weirdness of conscious experience. But here's where the paradox becomes almost dizzying. If consciousness is fundamental to how we understand reality, if observation plays a role in quantum mechanics, if the universe somehow requires conscious observers to collapse wave functions or select which version of reality becomes real, then consciousness isn't just a mysterious byproduct of brain activity. It's a key player in the cosmic drama itself. This brings us back to those ancient philosophical traditions that suggested consciousness is not produced by matter, but is instead a fundamental feature of reality itself. Perhaps consciousness doesn't emerge from complex arrangements of unconscious matter. Perhaps matter emerges from something deeper, something that includes consciousness as a basic ingredient. It's a view that sounds mystical but is taken seriously by some physicists and philosophers today. The implications are staggering. If consciousness is fundamental rather than emergent, then every electron, every photon, every quantum field might have some primitive form of experience associated with it. Not human-like consciousness, of course, but some basic subjective aspects that, when organized into sufficiently complex systems like brains, gives rise to the rich inner worlds we experience. This view, called panpsychism, suggests that the universe is not a collection of unconscious matter that somehow accidentally became aware of itself. Instead, it's a reality where experience and consciousness are woven into the very fabric of existence. Mind is not separate from matter. They're two aspects of the same underlying reality. It's a profound shift in perspective. Rather than consciousness being a rare and recent accident in an otherwise mindless universe, it becomes a fundamental feature of reality itself. The hard problem of consciousness, why there's something it's like to exist, dissolves because existence itself includes that experiential dimension from the ground up. But even if we accept that consciousness is fundamental, we're still left with profound mysteries. How does the simple, primitive consciousness that might exist at the level of particles combine and organize to create the rich, unified experience of being human? How do billions of possibly conscious neurons coordinate to create a single stream of experience? And why does your particular stream of consciousness feel like it belongs to you rather than someone else? These questions touch on what philosophers call the combination problem. How micro experiences might combine into macro experiences, and the boundary problem, where one conscious system ends and another begins. They're questions that push us to the very edges of human understanding, where science meets philosophy meets mystery. Perhaps most mysteriously of all, consciousness seems to be aware of itself. You're not just conscious, you're conscious of being conscious. You can observe your own thoughts, reflect on your own experiences, wonder about the nature of your own awareness. It's as if the universe, through conscious beings like us, has developed a capacity for self-reflection, for looking back on itself with wonder and curiosity. This recursive quality of consciousness, awareness aware of itself, creates an infinite regress that's both beautiful and bewildering. You can be aware of being aware in an endless loop of self-reflection that seems to point towards something infinitely deep about the nature of mind and reality. Standing at the edge of this mystery, we find ourselves in a curious position. We are the universe becoming conscious of itself, matter organized in such a way that it can contemplate its own existence, question its own nature, and wonder about its own purpose. Whether consciousness is an emergent property of complex brains or a fundamental feature of reality itself, it represents something extraordinary. The universe's capacity to experience itself from the inside. And perhaps that's the deepest paradox of all. In trying to understand consciousness, we're using consciousness to study itself. We're like eyes trying to see themselves, minds attempting to comprehend their own nature. Now we arrive at one of the most perplexing corners of our scientific journey, where the very nature of knowledge itself becomes tangled in paradox. We've explored the mysterious emergence of something from nothing, the spooky connections that bind quantum particles across impossible distances, and the hard problem of consciousness that refuses to yield to our most sophisticated theories. But there's another puzzle that strikes at the heart of how we understand understanding itself, and it emerges from the curious relationship between what we can know and what we can prove. This is the realm of mathematical paradoxes and logical impossibilities, where our most rigorous tools of reasoning turn back on themselves like a snake biting its own tail. Here, in the supposedly solid foundation of mathematics and logic, we find cracks that seem to threaten the very possibility of certain knowledge. It's a place where brilliant minds have constructed arguments so airtight they prove their own impossibility, where questions arise that cannot be answered not because we lack information, but because the questions themselves reveal fundamental limits to what can be known. Consider the ancient liar's paradox, deceptively simple yet profoundly unsettling. If it's true, then it must be false. If it's false, then it must be true. Round and round we go, trapped in an endless loop that seems to break the basic law that every statement must be either true or false. It's not just a clever word game, it's a glimpse into something deeper about the nature of truth and language itself. Or take Russell's paradox, which shattered the mathematical world in the early 20th century. Bertrand Russell was examining the foundations of set theory, the branch of mathematics that deals with collections of objects. He asked a seemingly innocent question. What about the set of all sets that do not contain themselves? Most sets don't contain themselves as members. The set of all cats doesn't contain itself because the set itself isn't a cat. But what about this special set, the set of all sets that don't contain themselves? If it contains itself, then it shouldn't be in the set, because the set only contains sets that don't contain themselves. But if it doesn't contain itself, then it should be in the set, because that's exactly what the set collects. This wasn't just an abstract puzzle for philosophers to ponder over tea, it struck at the very heart of mathematics, suggesting that even our most careful logical constructions could harbour hidden contradictions. The foundations that mathematicians thought were rock solid suddenly seemed to be built on quicksand. From these paradoxes emerged some of the most profound discoveries about the limits of knowledge itself. In the 1930s, a young mathematician named Kurt Gödel proved something that sent shockwaves through the academic world. His incompleteness theorems demonstrated that in any mathematical system complex enough to include basic arithmetic, there will always be true statements that cannot be proved within that system. In other words, mathematical truth is larger than mathematical proof. Imagine trying to build a perfect map of reality using mathematics and logic as your tools. Gödel showed that no matter how careful you are, no matter how sophisticated your system becomes, there will always be territories that remain unmapped, truths that slip through the net of formal proof. It's not that we haven't been clever enough or haven't worked hard enough, it's that the very nature of logical systems makes complete knowledge impossible. If the statement is false, then it can be proved, which contradicts what it says about itself. If it's true, then it indeed cannot be proved, which means the system contains a true statement that it cannot demonstrate. Either way, the system is either inconsistent or incomplete. But the strangeness doesn't end there. These limitations seem to extend beyond pure mathematics into the very fabric of how we reason about the world. Consider the halting problem discovered by Alan Turing. This asks whether we can determine, for any given computer program, whether it will eventually stop running or continue forever. Turing proved that no general solution to this problem can exist. There are programs whose behaviour cannot be predicted without actually running them, and some of those programs might run forever. This has profound implications for the dream of perfect prediction and control. It suggests that even in a completely deterministic universe, there are questions about the future that cannot be answered by any finite process of reasoning. The universe might be running a program that we cannot analyze from the outside. Then there's the unexpected hanging paradox, which reveals something unsettling about the relationship between knowledge and surprise. A judge tells a prisoner that he will be hanged on one of the 5 weekdays of the coming week, but the hanging will be a surprise. The prisoner will not know which day it will be until the morning of the execution. The prisoner reasons as follows: it cannot be Friday, because if Thursday passes without a hanging, I'll know it must be Friday, so it won't be a surprise. But if it can't be Friday, then it also can't be Thursday, because if Wednesday passes without a hanging, I'll know it must be Thursday. By the same logic, it can't be Wednesday, Tuesday or Monday either. Therefore, the prisoner concludes there can be no surprise hanging at all. But then, when the executioner arrives on Wednesday morning, the prisoner is genuinely surprised, because he had convinced himself it was impossible. The surprise hanging has succeeded precisely because the prisoner's reasoning led him to believe it couldn't happen. This paradox illuminates something profound about the relationship between logical reasoning and lived experience. Sometimes our very ability to reason about a situation changes the situation itself, creating blind spots in our knowledge that emerge from the act of knowing. These paradoxes aren't just intellectual curiosities, they point to something fundamental about the nature of truth, knowledge, and reality itself. They suggest that the universe might be inherently resistant to complete understanding, not because we're not smart enough, but because complete understanding creates its own impossibilities. In the quantum realm, we've already seen how the act of observation changes what is observed. In the realm of logic and mathematics, we find that the very frameworks we use to understand the world contain their own limitations, their own blind spots, their own internal contradictions. Perhaps most unsettling of all is the realization that these limitations cannot be overcome by building better logical systems. Gödel's theorems apply to any system rich enough to do basic mathematics. The halting problem cannot be solved by more powerful computers. The liar's paradox cannot be dissolved by more careful language. These are not bugs in our thinking, they are features of thought itself. They suggest that the universe is not just stranger than we imagine, but stranger than we can imagine. Not because our imagination is too limited, but because the very tools we use to imagine are subject to fundamental constraints. Yet there's something oddly comforting about these paradoxes as well. They remind us that mystery is not a problem to be solved, but a reality to be lived with. They suggest that the deepest truths might not be the ones we can prove, but the ones we can experience. They point toward a universe that is not a machine to be understood, but a mystery to be engaged with. Not a puzzle with a final solution, but an ongoing conversation between mind and reality. In confronting these paradoxes, we discover that uncertainty is not the enemy of knowledge, but its companion. The questions that cannot be answered are not failures of human reason, but invitations to a different kind of knowing, one that embraces paradox rather than resolving it, one that finds meaning not in final answers, but in the endless dance between question and response. As we stand at the edge of what can be known, we find ourselves not at the end of inquiry, but at its beginning, not at the limits of mystery, but at its heart. The vast cosmos stretches out before us, filled with mysteries that challenge our most fundamental understanding of reality. We've journeyed through the strange world of quantum mechanics, explored the warping of space and time, and witnessed the birth of mathematical paradoxes that defy our logic. Yet perhaps the most unsettling truth we've encountered is this: the very tools we use to understand the universe may be reaching their limits. Consider for a moment the extraordinary journey we've taken. We've seen how quantum entanglement suggests that reality itself might be non-local, that particles separated by vast distances can remain mysteriously connected in ways that seem to mock our classical understanding of space and time. We've explored how consciousness might be more than just the sum of neural activity, perhaps representing something fundamental about the universe itself. And we've witnessed how even our most rigorous mathematical systems contain truths that can never be proven within their own frameworks. But here's where things become truly fascinating and perhaps a little uncomfortable. Each of these paradoxes points to something deeper, something that suggests our entire approach to understanding reality might be incomplete. The measurement problem in quantum mechanics doesn't just challenge our understanding of particles and waves, it challenges the very notion that there's an objective reality independent of observation. The hard problem of consciousness doesn't just question how brains produce awareness, it questions whether the distinction between mind and matter is itself an illusion. What emerges from these mysteries is a pattern, a recurring theme that whispers through every paradox we've encountered. It's the suggestion that the universe might be fundamentally different from what our everyday experience tells us. Perhaps reality isn't made of separate, independent objects, interacting across space and time. Perhaps instead, everything is interconnected at the deepest level, woven together in ways that transcend our ordinary understanding of causality and locality. Think about the implications of this for a moment. If quantum entanglement reveals that particles can be instantaneously correlated across any distance, and if consciousness might be a fundamental feature of reality rather than an emergent property of complex matter, then perhaps the universe is more like a vast interconnected web of information and experience than a collection of separate things bumping into each other in empty space. This brings us to one of the most profound questions in all of science and philosophy. What if the very act of trying to understand the universe through reductionism, through breaking it down into smaller and smaller pieces, is fundamentally flawed? What if the whole is not just greater than the sum of its parts, but something entirely different from what those parts suggest? Modern physics has given us hints of this possibility. In quantum field theory, particles aren't really particles at all, but excitations in underlying fields that permeate all of space. In general relativity, space and time aren't fixed containers for events, but dynamic aspects of reality that bend and curve with matter and energy. Even in mathematics, Gödel's incompleteness theorems suggest that formal systems can never fully capture their own truths. Perhaps most intriguingly, these insights from the frontiers of knowledge seem to echo ancient wisdom traditions that have long suggested reality is far more unified and interconnected than it appears. From the Hindu concept of Brahman as the underlying unity of all existence, to the Buddhist notion of dependent origination, to the mystical traditions within Christianity, Judaism, and Islam, contemplatives have long reported experiences of reality as fundamentally one, despite its apparent multiplicity. But we need not rely on mystical insights alone. The scientific evidence itself points toward a reality that is far stranger and more interconnected than our ordinary experience suggests. When we probe deeply into the nature of matter, we find not solid particles, but probability waves. When we examine consciousness, we find not a thing produced by the brain, but perhaps something more fundamental, more mysterious. When we push the boundaries of logic and mathematics, we encounter paradoxes that suggest the limits of rational thought itself. This doesn't mean we should abandon science or reason. Rather, it suggests we might need to expand our understanding of what science and reason can tell us. Perhaps the greatest discoveries of the next century won't come from building bigger particle accelerators or more powerful telescopes, but from learning to think in new ways about the nature of reality itself. Consider the profound implications if consciousness is indeed fundamental to the universe. This wouldn't make us less significant, but more so. It would suggest that every moment of awareness, every experience of beauty or wonder or love, isn't just a byproduct of neural chemistry, but a genuine expression of something deep and fundamental about reality itself. We wouldn't just be observers of the universe, we would be the universe observing itself, coming to know itself through our investigations and experiences. And if quantum entanglement reveals that separateness is somehow illusory at the deepest level, then perhaps our sense of isolation and disconnection is also illusory. Perhaps we are all more deeply connected than we realize, not just through the atoms in our bodies that were forged in ancient stars, but through the very fabric of reality itself. These aren't just abstract philosophical speculations. They have profound implications for how we understand ourselves and our place in the cosmos. If consciousness is fundamental, then every being capable of experience participates in something sacred, something that transcends the purely material. If reality is deeply interconnected, then our actions and choices ripple through the fabric of existence in ways we can barely imagine. The paradoxes we've explored aren't problems to be solved so much as invitations to expand our understanding. They remind us that the universe is far stranger, far more wonderful and far more mysterious than we often allow ourselves to imagine. They suggest that the greatest truths might not be found in the answers we discover, but in the quality of questions we learn to ask as we stand at the threshold of even greater discoveries. Perhaps the most important thing we can cultivate is a sense of wonder and humility before the mystery of existence itself. The universe has been patient with our attempts to understand it, revealing its secrets gradually, often in ways that challenge our most basic assumptions. The least we can do is approach these revelations with the awe and respect they deserve. In the end, these unsolved paradoxes remind us that science at its best isn't about having all the answers, but about remaining open to possibilities we haven't yet imagined. They invite us to embrace mystery not as a failure of understanding, but as a doorway to deeper wisdom. And they suggest that the most profound truths about reality might not be captured in equations or theories, but experienced in moments of wonder, connection, and recognition of our place in the vast, mysterious, and ultimately unknowable cosmos we call home. The journey of discovery continues, and perhaps that's exactly as it should be. Throughout our journey, we've traced the cosmic threads that bind reality together, from the quantum realm to the expanding universe, from the mathematics that describes existence to the consciousness that observes it all. We've seen how each layer of mystery peels back only to reveal deeper questions like infinite Russian dolls of wonder. The universe, it seems, is not just stranger than we imagine. It may be stranger than we can imagine. Yet perhaps this endless mystery is not a limitation but a gift. Each unsolved paradox reminds us that reality extends far beyond our current understanding, that there are depths of truth still waiting to be discovered. The hard problem of consciousness suggests that our very ability to ponder these questions might be the most mysterious phenomenon of all. How remarkable that the universe has evolved beings capable of wondering about their own existence, of asking why there is something rather than nothing, of feeling awe at the quantum dance happening in every atom. In the dance between the known and unknowable, we find ourselves as both observers and participants. We are patterns of matter and energy that have somehow become aware of patterns of matter and energy. We are the universe contemplating itself, asking questions that may have no final answers, yet finding profound meaning in the asking itself. The mathematical frameworks we've explored, from Gödel's incompleteness theorems to the measurement problem in quantum mechanics, suggest that mystery isn't a bug in the system of reality, it's a feature. These paradoxes teach us humility. They remind us that for all our scientific advances, we are still taking our first tentative steps into understanding the true nature of existence. The quantum realm continues to defy our classical intuitions. Consciousness remains as puzzling as ever. The cosmos keeps expanding into we know not what, and perhaps that's exactly as it should be. A universe without mystery would be a universe without wonder, without the driving curiosity that propels us forward. As we close this exploration, remember that you are part of this grand cosmic story. The atoms in your body were forged in the hearts of dying stars. The quantum processes in your brain give rise to thoughts that can contemplate infinity. You are both infinitesimally small in the cosmic scale and infinitely precious as a conscious observer of it all. The unsolved paradoxes of science aren't just abstract puzzles, they're invitations to wonder, to question, to remain amazed by the sheer improbable miracle of existence itself. In the end, perhaps the greatest paradox is that, in a universe governed by physical laws, something as ephemeral as wonder, curiosity, and love can emerge. That in a cosmos that began with the simplest possible state, complexity and consciousness have bloomed like impossible flowers. The universe doesn't just contain mysteries, it is the mystery, and we are blessed to be part of its unfolding story. Looking at these reference transcripts and understanding the style needed, here's part 8 of the script about unsolved science paradoxes. we've ventured deep into the strangest corners of reality, from quantum mysteries to the nature of consciousness itself. We've seen how the universe seems to delight in presenting us with riddles that make our most brilliant minds scratch their heads and wonder if perhaps we're asking the wrong questions entirely. But now we arrive at something even more unsettling, something that strikes at the very heart of how we think we understand the world around us. We're about to explore paradoxes that don't just challenge our knowledge of physics or biology, but paradoxes that question the very foundations of knowledge itself. Welcome to the realm of epistemic paradoxes, where the tools we use to understand reality turn around and bite us, where logic leads us into circles that make our heads spin, and where the simple act of knowing something can become impossibly complicated. These aren't just academic curiosities tucked away in dusty philosophy journals. These are fundamental cracks in the very foundations of human reasoning, and they've been keeping brilliant minds awake at night for centuries. Let's start with something that sounds almost comically simple, but opens up a rabbit hole so deep that mathematicians are still falling down it. It's called Russell's paradox, named after the philosopher and mathematician Bertrand Russell. And it goes something like this. Imagine you're a librarian in the most organized library in the universe. You decide to create the ultimate catalogue, a master list of all catalogues that don't list themselves. Sounds reasonable enough, right? But then you hit a snag. Should this master catalogue list itself? If it lists itself, then it belongs to the category of catalogues that do list themselves, which means it shouldn't be in your master catalogue. But if it doesn't list itself, then it belongs to the category of catalogues that don't list themselves, which means it should be in your master catalogue. Round and round you go, trapped in an endless logical loop. This might seem like a silly word game, but Russell's paradox revealed something deeply troubling about the foundations of mathematics and logic. It showed that even our most basic concepts about sets and categories could lead us into contradictions. Mathematicians thought they'd built mathematics on solid logical ground, but Russell came along and showed them that their foundation was actually quicksand. The paradox sent shockwaves through the mathematical community and forced them to completely rebuild their understanding of how sets and logic work. Even today, over a century later, we're still dealing with the implications. But Russell's paradox is just the beginning. There's another paradox that cuts even deeper, one that questions whether we can ever really know if our systems of knowledge are truly reliable. It's called Gödel's incompleteness theorems, and while it might sound like dry mathematical theory, it's actually one of the most profound discoveries about the nature of truth and knowledge ever made. Kurt Gödel was a quiet, brilliant mathematician who in 1931 dropped a bombshell that's still reverberating through philosophy, mathematics, and computer science today. He proved something that seems almost impossible, that in any mathematical system complex enough to include basic arithmetic, there will always be true statements that cannot be proven within that system. Let that sink in for a moment. There are mathematical truths out there that we can never prove using the rules of mathematics itself. It's like discovering that no matter how perfect your toolbox is, there will always be jobs that your tools simply cannot handle. You might know that a statement is true, you might even be absolutely certain of it, but you'll never be able to prove it using the logical system you're working within. Even more unsettling, Gödel showed that no mathematical system can prove its own consistency. We can never be absolutely certain that our mathematical foundations won't eventually lead us into contradiction. This creates what philosophers call the problem of the criterion. How do we know what we know? If we want to establish that something is true, we need criteria for truth. But to establish that our criteria are reliable, we need criteria for our criteria. And to establish that those criteria are reliable, we need criteria for our criteria for our criteria. It's an infinite regress that seems to make the whole enterprise of knowledge impossible. Some philosophers have tried to escape this by appealing to self-evident truths or basic intuitions, but others point out that what seems self-evident to one person might seem questionable to another. Throughout history, many things that seemed obviously true turned out to be completely wrong. The Earth seemed obviously flat until we discovered it was round. The Sun seemed obviously to revolve around the Earth until we realized it was the other way around. If our most basic intuitions can be so dramatically mistaken, how can we trust them as foundations for knowledge? This leads us to an even more disturbing possibility, the problem of skepticism. If we can never be absolutely certain about our foundations of knowledge, how do we know that anything we believe is actually true? Maybe we're all just brains in vats being fed artificial experiences by some cosmic scientist. Maybe reality is just a simulation running on some unimaginably powerful computer. Maybe everything you think you know about the world is just an elaborate illusion. The philosopher René Descartes tried to solve this problem by doubting everything he could possibly doubt, hoping to find at least one thing he could be absolutely certain about. He eventually settled on, "I think, therefore I am," as his bedrock of certainty. Even if everything else was an illusion, the fact that he was doing the thinking seemed undeniable. But even this seemingly solid foundation has been questioned. How do we know that the I doing the thinking is a single continuous entity? How do we know that thoughts require a thinker? Eastern philosophers have long suggested that the sense of self might itself be an illusion. These questions might seem abstract and philosophical, but they have real implications for how we understand science, truth, and reality. If we can never be absolutely certain about our foundations of knowledge, what does that mean for scientific theories? What does it mean for the very project of trying to understand the universe? Some philosophers and scientists have embraced what's called fallibilism, the idea that all human knowledge is provisional and subject to revision. We can never achieve absolute certainty, but we can build increasingly reliable and useful models of reality. Science doesn't give us absolute truth, but it gives us better and better approximations. Our knowledge is always incomplete and potentially mistaken, but it's still the best we can do. Others have taken a more radical approach, suggesting that the search for absolute foundations of knowledge is misguided from the start. Maybe knowledge doesn't need to be built on absolutely certain foundations. Maybe it's more like a web or a network, where beliefs support each other in complex, interconnected ways. No single belief needs to be absolutely certain, as long as the overall web is coherent and useful. But perhaps the most unsettling epistemic paradox of all is the paradox of analysis. When we try to analyze or understand something, we break it down into simpler components. But if our analysis is correct, then it's just telling us something we already knew, in which case it's trivial. But if our analysis is telling us something new and informative, then it can't be correct, because we're adding information that wasn't there in the original concept. So analysis seems to be either trivial or incorrect, never both informative and true. This paradox strikes at the heart of all intellectual inquiry. Every time we try to explain something, every time we try to understand what's really going on beneath the surface, we run into this fundamental problem. How can we gain new knowledge through analysis if analysis either tells us nothing new or tells us something false? These epistemic paradoxes reveal something profound and unsettling about the human condition. We are creatures who desperately want to understand, to know, to make sense of our world and ourselves. But the very tools we use for understanding seem to have built-in limitations and contradictions. We can never step outside of our own perspective to get a truly objective view of reality. We can never achieve absolute certainty about anything. We can never even be sure that our methods of inquiry are ultimately reliable. And yet, somehow, we keep going. We keep building theories, conducting experiments, writing philosophy, creating art, and trying to make sense of it all. Maybe the paradoxes don't destroy the possibility of knowledge so much as they humble us. They remind us that the universe is stranger and more complex than our minds can fully grasp. They teach us to hold our beliefs lightly, to remain open to new possibilities, and to embrace the mystery rather than trying to eliminate it. Perhaps the deepest truth that these epistemic paradoxes reveal is that uncertainty is not a bug in the system of human knowledge. It's a feature. Maybe the fact that we can never achieve absolute certainty is not a failure, but a gift. It keeps us curious, keeps us questioning, keeps us humble in the face of the vast mystery of existence. In the end, these paradoxes of knowledge might be pointing us toward a different way of thinking about truth and understanding. Instead of seeking absolute foundations and final answers, maybe we should embrace the ongoing conversation between mind and reality, the endless dance of question and discovery that makes us human. The strange thing about our universe is that it seems to know exactly when to say no. We've explored 8 profound mysteries so far, from the quantum realm's refusal to reveal its secrets to time's stubborn insistence on moving in only one direction. But perhaps nowhere is this cosmic stubbornness more beautifully displayed than in the realm of information itself. Because it turns out there are fundamental limits to what we can know, boundaries carved not by our technology or intelligence, but by the very structure of reality. Let's begin with something that sounds almost too philosophical to be physics: the holographic principle. This isn't about those shimmering stickers you collected as a child or the security features on your credit card. This is about the possibility that everything you think you know about reality, every depth and dimension you experience, might actually be encoded on a distant 2-dimensional surface, like shadows dancing on the wall of Plato's cave. The idea emerged from studying black holes, those cosmic monsters that devour everything, including light itself. For decades, physicists puzzled over what Stephen Hawking called the information paradox. When matter falls into a black hole, what happens to the information it contains? According to quantum mechanics, information cannot be destroyed. It's a fundamental conservation law, as sacred as the conservation of energy. But black holes seem to violate this principle, swallowing information whole and never giving it back. Then came a radical proposal. What if the information never actually falls into the black hole at all? What if it's somehow encoded on the black hole's event horizon, the point of no return surrounding it? This surface, measured in square units rather than cubic ones, might contain all the information about everything that ever fell in. The 3-dimensional drama of matter spiraling toward doom might actually be a holographic projection of 2-dimensional data. But the implications stretch far beyond black holes. If this principle holds universally, then our entire 3-dimensional reality, with all its depth and substance, might be nothing more than a holographic projection of information encoded on some distant boundary. Every atom in your body, every thought in your mind, every star in the sky, all of it could be shadows cast by patterns written on the edge of the observable universe. Think about that for a moment. The coffee cup in your hand, solid and warm, and undeniably real, might be no more substantial than the image on a movie screen. The difference is that this movie is being projected from the very boundaries of space itself, and we are not the audience watching the show. We are characters within it, holographic beings experiencing a holographic world without ever suspecting the truth. This leads us to an even stranger limitation, one that strikes at the heart of information itself. It's called the Bekenstein bound, named after physicist Jacob Bekenstein, who discovered that there's a maximum amount of information that can be stored in any given volume of space. It's not a practical limit like running out of hard drive space, it's a fundamental law of nature. The bound tells us that information, like energy and matter, has physical reality. It takes up space in a very real sense, and there's only so much of it that can fit in any region of the universe. This limit is set by the area, not the volume, which connects back to the holographic principle. It's as if the universe has a built-in compression algorithm, ensuring that reality never exceeds its storage capacity. But here's where it gets deliciously paradoxical. If there's a limit to how much information can exist in any volume of space, then there's also a limit to how much we can know about that space. We can't have perfect knowledge of a system because perfect knowledge would require more information than the system itself can contain. It's like trying to write a complete catalogue of a library on a single page. The catalogue would need to be larger than the library itself. This connects to another deep mystery, the measurement problem in quantum mechanics. Every time we try to measure a quantum system, we seem to collapse its wave function, forcing it to choose one reality from among many possibilities. But this process appears to destroy information about all the other possibilities that didn't happen. Where does that information go? Does it simply vanish, violating conservation laws? Or does it somehow persist in parallel universes, creating an ever-branching tree of realities? The many worlds interpretation suggests the latter, but this creates its own information paradox. If every quantum measurement splits the universe into multiple branches, then the total amount of information in the multiverse grows exponentially with each passing moment. How can the universe sustain this explosion of information? Either the many worlds interpretation leads to an infinite information catastrophe, or there's some deeper principle we don't understand that limits the proliferation of realities. Then there's the observer effect, the strange fact that the very act of observation seems to change what we observe. This isn't just about clumsy instruments disturbing delicate systems. It's a fundamental feature of quantum mechanics. Information about a quantum system can only be extracted by interacting with it. An interaction inevitably changes the system. We can never step outside the dance to watch from the sidelines. We are always participants, always influencing what we're trying to understand. This leads to what physicists call the knowledge-reality trade-off. The more precisely we try to measure one aspect of a quantum system, the more we disturb other aspects. Heisenberg's uncertainty principle isn't just about position and momentum, it's about the fundamental impossibility of having complete information about anything. The universe seems to guard its secrets jealously, revealing some truths only by concealing others. Consider the strange case of quantum entanglement again, those spooky correlations that Einstein found so troubling. When two particles are entangled, measuring one instantly affects the other, no matter how far apart they are. But here's the paradox. While the correlation is real and measurable, it cannot be used to transmit information faster than light. The universe allows instantaneous correlation, but forbids instantaneous communication. It's as if reality has built-in firewalls, preventing us from exploiting quantum weirdness to break causality. This connects to a deeper principle called the no communication theorem. Despite all the strangeness of quantum mechanics, all the wave-particle duality and measurement problems and entanglement, the theory is carefully constructed to prevent any violation of relativistic causality. Information cannot travel faster than light, not because of technological limitations, but because the mathematics of quantum mechanics itself forbids it. But perhaps the deepest information paradox of all concerns consciousness itself. We are information processing systems trying to understand information processing. We are patterns of matter and energy attempting to comprehend the patterns that constitute our own existence. It's a recursive loop that threatens to collapse into infinite regress. How can a system completely understand itself? How can the knower fully know the knowing? This leads to what philosopher David Chalmers calls the hard problem of consciousness. We can map every neuron in the brain, trace every electrical impulse, catalogue every chemical reaction, but the subjective experience of being conscious, the inner theatre where thoughts and feelings play out, remains mysteriously elusive. Perhaps this isn't a failure of science, but a fundamental limitation. Perhaps consciousness is the one thing that cannot be fully explained from the outside because explanation itself is a conscious activity. The information paradoxes run even deeper when we consider the arrow of time. Information theory tells us that entropy, the measure of disorder, always increases in closed systems. But information is the opposite of entropy. It's organized, meaningful, purposeful. So how does information arise in a universe that's constantly sliding toward maximum entropy? How do patterns persist and evolve in a cosmos dedicated to erasing all patterns? This is sometimes called the Maxwell's demon paradox. Imagine a tiny creature that could sort fast-moving molecules from slow-moving ones, creating order from chaos and seemingly violating the second law of thermodynamics. The resolution involves information. The demon would need to measure and remember the speeds of molecules, and the act of forgetting this information would generate entropy, preserving the second law. But this raises profound questions about the relationship between information, memory, and the flow of time. Then there's the frame problem in artificial intelligence, the difficulty of determining what information is relevant in any given situation. Humans navigate this effortlessly, ignoring countless irrelevant details while focusing on what matters. But creating machines that can do the same has proven remarkably difficult. How do we know what we need to know? How do we recognize the boundaries of relevance? These questions reveal deep mysteries about how intelligence itself operates. The computational theory of mind suggests that thinking is a form of information processing, but this leads to new paradoxes. If minds are computational systems, then they should be subject to the limits discovered by mathematicians like Gödel and Turing. Gödel showed that no mathematical system can prove all truths about itself, while Turing proved that there's no general algorithm for determining whether a program will halt or run forever. Do these limitations apply to minds as well? Are there truths we can never prove and problems we can never solve, not because of practical constraints, but because of the fundamental nature of computation itself? This brings us full circle to the holographic principle and the nature of reality itself. If our three-dimensional world is indeed a projection from a two-dimensional boundary, then we are living inside an information processing system of unimaginable complexity. Every physical law, every particle interaction, every conscious experience would be the result of computations performed on this cosmic surface. We would be literally made of information, temporary patterns in an ongoing calculation. But this raises the ultimate question: what is computing the hologram? What lies beyond the boundary where our reality is encoded? Is there a meta-reality, a higher dimensional space where the true physics plays out? Or is it information all the way down, an infinite hierarchy of computational levels with no final ground of being? These information paradoxes remind us that knowledge itself has limits, that there are boundaries to what any conscious being can know about the universe or about itself. We are finite minds trying to grasp infinite complexity, temporary patterns trying to understand the permanent laws that govern all patterns. Perhaps the deepest truth is that some mysteries are meant to remain mysterious, that the universe preserves certain secrets, not out of malice, but out of logical necessity. The next time you process information, whether reading these words, remembering a face, or simply being conscious of your own existence, remember that you are participating in one of the deepest mysteries of all. Information is not just data flowing through circuits or patterns stored in memory. It's the very fabric from which reality might be woven. We've journeyed through the architecture of reality itself, from the quantum foam where particles dance in and out of existence, to the cosmic web where galaxies hang like dewdrops on invisible threads. We've wrestled with paradoxes that bend logic into impossible shapes, watched time stretch and compress like taffy in a cosmic carnival, and peered into the strange mathematics that governs everything, from the smallest electron to the largest black hole. Throughout this exploration, we've encountered the fundamental limits of knowledge itself. Gödel showed us that even mathematics, our most precise language, contains statements that cannot be proven within its own framework. The halting problem demonstrated that computation itself has boundaries, invisible walls that even the most powerful computers cannot breach. The measurement problem in quantum mechanics revealed that the very act of observation seems to collapse reality into a single outcome from a sea of possibilities. And yet perhaps the most profound paradox is this: the more we discover about the universe's mysteries, the more mysterious it becomes. Each answer births new questions. Each solution reveals deeper puzzles. The holographic principle suggests that all the information in a volume of space might be encoded on its boundary, like a cosmic shadow play where three-dimensional reality emerges from two-dimensional information. Information itself appears to be the fundamental currency of the universe, more basic than matter or energy. We've seen how consciousness, that most intimate aspect of our existence, remains stubbornly resistant to explanation. The hard problem of consciousness stands like a sphinx at the gates of understanding, asking riddles we cannot yet answer. How does the electrochemical firing of neurons give rise to the rich inner landscape of experience? How does the brain's 3 pounds of tissue generate the feeling of being you? Even our most cherished notions of causality and locality have been challenged. Quantum entanglement suggests that particles can be connected across vast distances in ways that seem to violate the speed of light, yet somehow preserve the deeper structure of space-time. The universe appears to be non-local, meaning that events here can be correlated with events there in ways that transcend our everyday understanding of space and time. The arrow of time itself, that most basic feature of our experience, may be nothing more than a statistical accident, a consequence of the universe's journey from low entropy to high entropy. Time might not flow at all, but rather exist as a dimension through which we move, like travelers on a cosmic highway who mistake their motion for the motion of the road itself. Russell's paradox and its cousins have shown us that even the most fundamental concepts, like the notion of a set, can lead to contradictions when pushed to their limits. The very foundations of mathematics, once thought to be unshakable, turn out to rest on assumptions that cannot be proven. We build our knowledge on shifting sand, yet somehow the structures we create remain standing. These paradoxes and mysteries are not failures of human understanding, but rather signposts pointing towards something deeper. They remind us that the universe is under no obligation to conform to our intuitions or yield to our methods. They teach us humility in the face of the infinite, wonder in the presence of the incomprehensible. Perhaps the greatest paradox of all is that we, as conscious beings made of star stuff, can contemplate these mysteries at all. We are the universe becoming aware of itself, asking questions about its own nature. In a cosmos that began as a hot, dense state and evolved over billions of years into the complex tapestry we see today, the emergence of minds capable of pondering existence itself is perhaps the most remarkable phenomenon of all. The dance between knowledge and mystery, between understanding and wonder, is not a problem to be solved, but a tension to be embraced. It is the engine of discovery, the source of awe, the foundation of wisdom. In recognizing the limits of our knowledge, we paradoxically expand our capacity for wonder. In accepting the mysteries we cannot solve, we open ourselves to the beauty of questions that may have no answers. And so we find ourselves at the end of this journey, but also at the beginning. For every mystery we've explored opens onto others. Every paradox we've encountered hints at deeper truths waiting to be discovered. The universe keeps its secrets jealously, but it also keeps revealing new ones, ensuring that the quest for understanding will never end. In this eternal dance between the known and the unknown, between the explicable and the mysterious, we find not cause for despair, but reason for celebration. For in a universe where all questions had answers, where all mysteries were solved, where all paradoxes were resolved, there would be no room for wonder, no space for discovery, no invitation to explore. The very fact that profound questions remain is what makes the journey worthwhile. The universe is not a puzzle to be solved, but a mystery to be lived. And in that living, in that questioning, in that eternal reaching toward understanding, we find perhaps the deepest truth of all, that consciousness, with all its questions and wonder, is not separate from the cosmos, but its most intimate expression. We've explored the mind-bending puzzles of quantum mechanics, delved into the mathematical impossibilities of Gödel's theorems, and stared into the abyss of consciousness itself. Yet as we near the end of our journey, through the labyrinth of unsolved paradoxes, there remains one final frontier that challenges everything we think we know about knowledge itself. It's a realm where the very act of seeking truth becomes tangled with the fundamental nature of reality, where information meets its limits, and where the universe seems to whisper that some mysteries might be forever beyond our grasp. This is the domain of computational irreducibility, the halting problem, and what we might call the ultimate epistemological boundary. It's where mathematics collides with philosophy, where computer science meets cosmology, and where we discover that the universe might be fundamentally uncomputable. Let's begin with a deceptively simple question. If you have a computer program, can you always determine whether it will eventually stop running or continue forever? This innocent query, known as the halting problem, was proven impossible to solve, in general, by Alan Turing in 1936. But its implications stretch far beyond computer science into the very heart of what we can know about reality. The halting problem reveals that there are mathematical questions that are not just difficult to answer, they're impossible to answer. No algorithm, no matter how sophisticated, can look at an arbitrary computer program and definitively say whether it will halt or run forever. This isn't a limitation of current technology or human ingenuity. It's a fundamental logical impossibility, as absolute as the fact that you cannot create a square circle. But here's where it gets truly profound. According to computational theories of physics, our universe itself might be viewed as a vast computational process. Every particle interaction, every quantum measurement, every moment of time's passage could be seen as steps in an enormous calculation. If this view is correct, then the halting problem suggests there are aspects of the universe's future that are not just unpredictable in practice, but unpredictable in principle. This connects to Stephen Wolfram's concept of computational irreducibility. In many systems, even simple ones, the only way to find out what will happen is to actually run the system and see. You cannot shortcut the process. The future is compressed into the present in such a way that prediction requires simulation, and simulation takes just as long as the real thing. Consider the three-body problem in physics. When three objects interact gravitationally, their long-term behavior becomes chaotic and unpredictable. But computational irreducibility suggests something deeper. Even if we had perfect knowledge of initial conditions and infinite computational power, there might still be no shortcut to determining the system's behavior, other than letting it evolve naturally. This principle extends beyond physics into biology, economics, and consciousness itself. The human brain, with its billions of neurons forming trillions of connections, might be computationally irreducible. Even if we mapped every synapse and understood every chemical interaction, predicting consciousness might require simulating consciousness, which brings us no closer to understanding it. Here we encounter another paradox within the paradox. If consciousness is computationally irreducible, then any complete theory of mind would need to be as complex as mind itself. We'd need a brain to understand a brain, a conscious system to fully comprehend consciousness. The observer and the observed become inextricably entangled in an epistemological loop. This touches on the ancient philosophical problem of the criterion. To know something, we need criteria for distinguishing truth from falsehood. But to establish these criteria, we need to know something already. How do we bootstrap knowledge without falling into circular reasoning? The computational perspective suggests this circularity might be fundamental, not just a quirk of human reasoning. Consider Gödel's incompleteness theorems again, but now through the lens of computation. Gödel showed that any mathematical system complex enough to do arithmetic contains statements that cannot be proven within that system. But the halting problem reveals something even more troubling. There are mathematical truths that cannot be computed at all. They exist, they're definite, but they're forever beyond the reach of any algorithm. This creates what we might call the knowledge horizon. Just as black holes have event horizons beyond which information cannot escape, mathematics and physics seem to have knowledge horizons beyond which truth cannot be computed or proven. We can know these horizons exist, but we cannot cross them. The implications ripple through every domain of human inquiry. In physics, we've already encountered the measurement problem in quantum mechanics, but computational irreducibility suggests the problem runs deeper. If quantum systems are computationally irreducible, then the act of measurement might not just disturb the system, it might be the only way to extract certain types of information from it. The universe doesn't just hide information from us, it might structure itself so that some information can only be accessed through irreversible acts of observation. This connects to the holographic principle and the Bekenstein bound we discussed earlier. These suggest that the amount of information that can be contained in any region of space is finite and related to the region's surface area, not its volume. But computational irreducibility adds another layer. Even if information is finite, extracting it might require computations that take longer than the age of the universe. We're left with the strange picture of reality. The universe might contain definite truths that are forever unknowable, not because they're hidden or because we lack the tools to find them, but because the very structure of logic and computation makes them inaccessible. It's as if reality has built-in privacy settings that cannot be overridden. This doesn't mean science is futile or that we should abandon the search for understanding. Rather, it suggests that mystery isn't just an accident of our current ignorance. It's woven into the fabric of existence itself. S. Haldane once said, "It might be stranger than we can imagine, not due to limitations of human creativity, but due to fundamental limits on what any conscious system can know about itself and its environment." Perhaps this is the deepest paradox of all. In seeking to understand everything, we discover that everything cannot be understood. The very success of science in pushing back the boundaries of ignorance reveals the existence of boundaries that cannot be crossed. We are conscious beings, embedded in a reality that might be fundamentally uncomputable, using minds that might be computationally irreducible to study a universe that contains truths beyond the reach of any algorithm. Yet there's something beautiful about this ultimate limitation. It ensures that wonder never dies, that there will always be mysteries at the edge of knowledge, that the universe retains its capacity to surprise us. In a fully computable, fully predictable cosmos, consciousness might be unnecessary. Mystery, it seems, is not the enemy of understanding, but its eternal companion, the shadow that gives meaning to the light of knowledge. As we stand at this final horizon, we realize that the greatest paradox might be the existence of consciousness itself in a universe where so much remains forever unknowable. And so we arrive at the end of our long journey through the mysterious landscape of unsolved scientific paradoxes. We've travelled together through the deepest questions that have puzzled humanity for millennia, those stubborn mysteries that seem to dance just beyond the reach of our understanding. From the quantum realm, where particles exist in impossible superpositions, to the cosmic scale, where dark matter and dark energy dominate a universe we can barely comprehend. We've seen how every answer science provides seems to whisper 3 new questions in return. Perhaps the most humbling realization from our exploration is that mystery isn't a failure of science, but its very essence. The paradoxes we've encountered aren't bugs in the cosmic code, they're features, fundamental aspects of a reality that may be far stranger and more beautiful than our minds can fully grasp. When we peer into the quantum world and find particles that can be in multiple places at once, when we discover that information itself might be the bedrock of reality, when we realize that consciousness, the very thing doing the observing, remains completely enigmatic, we're not witnessing the limits of scientific inquiry, but glimpsing the infinite depth of existence itself. The hard problem of consciousness reminds us that the most intimate aspect of our experience, the simple fact that there's something it's like to be you, remains as mysterious today as it was to the first human who wondered about their own thoughts. The measurement problem in quantum mechanics shows us that the act of observation itself seems to collapse infinite possibilities into singular realities, suggesting that consciousness and cosmos are intertwined in ways we're only beginning to suspect. And the binding problem reveals that even our most basic perceptions, the unified experience of seeing a red apple or hearing a familiar song, emerge from processes we cannot yet explain. Information paradoxes tell us that reality might be fundamentally computational, that what we think of as solid matter and empty space might be expressions of deeper informational structures. The holographic principle suggests that everything we see around us, every tree and star and grain of sand, might be projections from a two-dimensional surface we cannot perceive. These aren't just abstract theoretical musings, they point toward a universe that operates on principles so alien to our everyday experience that we lack even the proper language to describe them. Yet perhaps the most profound paradox of all is that we conscious beings, made of star stuff and quantum uncertainty, can contemplate these mysteries at all. We are the universe becoming aware of itself, matter organized in such a way that it can ponder its own existence. The fact that collections of atoms can experience wonder, can feel the weight of unsolved questions, can lose themselves in the beauty of mathematical equations or the elegance of physical laws, is itself a mystery that transcends any particular scientific discipline. The cosmic paradoxes we've explored, the fine-tuning problem, the Fermi paradox, the mystery of cosmic inflation suggests that we exist in a reality balanced on the knife's edge of possibility. Change any fundamental constant by the tiniest fraction, and stars don't form, atoms don't bind, life never emerges. Whether this points to a multiverse of infinite possibilities, to design beyond our comprehension, or to principles we haven't yet discovered, it reminds us that existence itself is improbable, precious, and utterly astonishing. And through it all, we've seen how each generation of scientists has pushed against the boundaries of the known, only to discover that those boundaries recede like horizons, always revealing new landscapes of mystery beyond. Newton's clockwork universe gave way to Einstein's relativistic cosmos, which in turn yielded to the quantum realm's probabilistic dance. Each paradigm shift hasn't eliminated mystery, but deepened it, shown us that reality is stranger, more subtle, more interconnected than we ever imagined. The bootstrap paradox in cosmology and quantum mechanics suggests that perhaps causation itself might be more circular than we suppose, that effects and causes might be woven together in ways that transcend our linear thinking. The observer effect reminds us that we cannot separate ourselves from what we study, that the act of investigation changes both the investigator and the investigated. And the incompleteness theorems show us that, even in the abstract realm of mathematics, there are truths that cannot be proven within any system, suggesting that mystery might be hardwired into the very foundations of logic itself. But rather than being discouraged by these limits, we can find in them a profound invitation. The unsolved paradoxes of science aren't roadblocks, they're doorways, each one leading to deeper questions, richer mysteries, more beautiful unknowns. They remind us that wonder is not a feeling to be outgrown, but a faculty to be cultivated, that the capacity to be astonished by existence is perhaps our most precious gift. In the quiet moments when you look up at the night sky, remember that those distant stars are not just burning balls of gas, but cosmic laboratories where the very elements of your body were forged. When you observe the play of light and shadow, remember that photons have travelled vast distances and unimaginable spans of time to reach your eyes, carrying information about the deepest structures of reality. When you experience the simple miracle of consciousness, of being aware that you are aware, remember that you are participating in one of the universe's greatest unsolved mysteries. The paradoxes we've explored together, consciousness and cosmos, information and infinity, quantum uncertainty and cosmic fine-tuning, point toward a reality that is not just stranger than we imagine, but perhaps stranger than we can imagine. Yet this strangeness is not alien to us, we are expressions of it, temporary arrangements of atoms and energy that have somehow acquired the ability to contemplate their own existence. Science may never solve all its paradoxes, and perhaps that's exactly as it should be. For it is in the space between question and answer, in the tension between the known and the unknown, that wonder lives. It is in our willingness to embrace mystery, to sit comfortably with uncertainty, to find beauty in the questions themselves, that we discover not just new facts about the universe, but new ways of being human within it. So as you drift off to sleep tonight, let your mind wander among these cosmic mysteries. Let yourself feel the weight of the unknown, the thrill of the impossible, the quiet joy of existing in a universe full of paradoxes. For you are not separate from these mysteries, you are one of them, a conscious paradox contemplating its own existence, a brief flame of awareness in the cosmic dark, beautiful precisely because you burn so briefly, precious precisely because you're so improbable. The universe keeps its secrets well, but it has shared one with you, the secret of your own consciousness, your own capacity for wonder, your own ability to ask questions that echo in the infinite spaces between the stars. That might be the greatest paradox of all, and the most wonderful answer we'll ever find. Sweet dreams, fellow travellers in the mystery. The cosmos is vast, the questions are endless, and tomorrow there will be new paradoxes to ponder, new mysteries to embrace, new reasons to marvel at the strange and beautiful impossibility of it all.